Welcome back everyone. In this video we're going to be talking about how to calculate angles on right angle triangles, and quickly we're just going to review trig ratios, talk about inverse trig functions, and then we're going to show you how to calculate some angles. So first we need to go over trigonomic ratios and how we can remember them. Now in the last video we talked about SOH, CAH, TOA and how that can help us remember and what each stood for. So SOH, S-O-H, stood for sine of theta is equal to the ratio of the opposite over the hypotenuse. CAH, or C-A-H, equaled cos theta equaled the ratio between adjacent over hypotenuse. Finally, TOA equaled tan theta, or the ratio between the opposite over the adjacent. Now, how we got these was labeling our triangles. So our longest side was always called our hypotenuse, and then the other two relied on the reference angle. So we would draw an arrow across on that angle and label that as the opposite, and then a little arrow down, and that was the adjacent, or the angle next to the hypotenuse. Now we're just going to talk about inverse functions and what they are. So you'll see here these sine, cos and tan. They have that small -1 above them. And what they mean, they're the inverse to our regular sine, cos and tan functions. And like multiplying is the opposite to dividing, and addition is the opposite to subtraction, if you do the inverse sine of sine 5, it just equals 5. Same as the inverse cos of cos 27, it just equals 27. And inverse tan of tan 43 just equals 43. So they actually undo each other. Like if we did 4 times 3 divide 3, it undoes that multiplication, so it's just left with 4. And similarly, this also works with addition and subtraction. Now we're just going to do a few examples. So here we have a triangle where we have our opposite, an adjacent and our hypotenuse labelled. And we have a hypotenuse and an adjacent. So up the top we'll see that the only one that uses that is cos. So we're going to fill out the formula for cos of cos theta equals the adjacent over the hypotenuse. Now we're just going to populate it with our values. So cos theta equals 3 over 5. And because we're looking for that theta, now we need to undo that cos. So we're going to use that inverse function. So inverse cos of 3 over 5. And that'll give us the theta value. So that's all we have to do. And theta here equals 59.03. Okay. And that's in degrees, but that's all you need to do. So you're always just using that inverse function to find the angle. Now here we're going to label our triangle again using our reference point. So we have the opposite and the hypotenuse in this example. So we'll label our triangle, and then we're just going to go through and pick which trig ratio works for us. So here we have the opposite and the hypotenuse. So the only one that has those is sine. So we're going to write out our formula. Sine theta equals the opposite over the hypotenuse. Sine theta equals 14 over 21. And now, because we're looking for that theta function, we just use our inverse sine function. So theta equals inverse sine over 14 over 21. So theta equals 46.46. And that's in degrees. You need to remember to put that degrees, or you will lose marks for not putting your units in there. Now we're just going to quickly do one more example. Again, this is still a right angle triangle, even though it's flipped. So we label our triangle, we have an opposite and an adjacent. So the only ratio that uses that is tan. So we'll write out tan theta equals the ratio of opposite over adjacent. Now we populate using our figures. So tan theta equals 12 over 15. And now to remove that tan, we need to use the inverse function. So theta equals tan inverse, or inverse tan, of the ratio of 12 over 15. Okay, and these are found on your calculators, and you don't need to do any of this mentally. It's all done for you. So theta equals 42.96. And that's all there is to calculating these missing angles. So we'll leave it at there for this video. Hopefully that wasn't too difficult and you understand how to do that, and we'll see you next time.